Good afternoon. My name is Jonathan Wynn, and I'm excited to be here this afternoon at the Actuarial Technology Summit, speaking on Excel as a full stack data science platform. Before we dive into that, though, here's our antitrust notice, just so we can be assured that everything we're doing here is above board at this conference. And maybe even more importantly, we want to have a big thanks to our sponsors for putting on this conference today. Thank you all very much. Before we dive in, I just wanted to say a little bit of background about myself. So I'm a property casualty actuary. I'm a fellow of the CAS. Um, had that for about 10 years, so getting on up there in my own years. About 18 years of consulting and in-house actuarial experience. So working at a carrier, working in consulting, and now I'm currently at a Big Four doing a lot of things you might expect there, like audit support, traditional reserve related consulting services, and also some due diligence. But all that is to say is, while some actuaries really focus on the pricing and product side, I'm much more on the finance and risk side of the spectrum. So that's what's formed a lot of my thinking on these topics. Today's agenda, first off, we're going to start going over recent updates to Microsoft Excel. When this conference was first getting together, I thought about making that the entire focus of my presentation. However, I did notice that there are some really good topics that go into, or really good speakers that are going to have some deep dives into particular topics, and I don't want to, you know, I don't want to, take away from their limelight. So we're going to just briefly go over recent updates to Excel. Maybe about a third of our time will be spent on that, going through at a really high level. I'll show a few examples, but it won't be much of a how-to as much as a this is what's out there. And I will point you to some resources if you want to kind of learn and grow yourself after the conference ends. And then we'll get into kind of the main idea from today's talk, which is Excel as a full stack data science platform. What does that mean, and how can we understand it as such? And in particular, we're going to focus on two features contributing to that paradigm. One, Power Query, and two, Python and Excel. And then we'll have just a few concluding thoughts. We'll open it up for discussion. I'm really curious what everyone thinks, as this is a heavily used product by the actuarial community, and it's a product that's always changing, and just about everyone has strong feelings about it. So I'm really looking forward to Q&A at the end. So with that, recent updates to Microsoft Excel. Now, again, if you're a heavy Excel user, you know that a lot of changes have been rolling out over the last 10 or 15 years. Um, I've grouped a lot of the major changes here under two headers. One, things that are available locally. You don't need, Excel on the web. You don't need to be able to connect to some sort of a Microsoft cloud. But these are things that you can just get on like your home Excel version. Now there are also features that are really designed for use with a connection to the web, and maybe a few things that don't even work if you can only run Excel locally. Um, Kind of starting on that first header, we're going to look at dynamic array formulas. Um, Now, the real takeaway here is that if you have to, work with maybe a matrix or an array, you no longer have to hit Control Shift Enter if you want Excel to recognize that range as such. So, if you're doing array calculations, matrix calculations, they're handled in a very fluid, very natural feeling way, just like if you're working with R, passing arrays and vectors around. Um, if you want to indicate an array or reference an array, you would just add a hash after your Excel reference. And while it's pretty huge that you can now work with arrays in a pretty natural way in Excel, there's also a growing suite of functions that support array calculations, and they're and that suite is continually growing. If you kind of monitor the Excel development blog, you'll kind of see like new functions roll out a few every year at this present time. But I'm going to show you just a couple of quick examples of what I'm talking about. So just bringing up an Excel spreadsheet, I'm just going to type in a short series of numbers, and then I'm just going to reference this as an array and we'll see what happens. So you can see that, I have this little blue range that's been indicated here. Now, if I want to, say I just want to shift everything over by 2, I can do that in a very natural way by pointing to the lead cell in that array, typing in hash after it, and then just adding 2, and you can see everything is kind of shifted over naturally by 2. So, this is obviously a simple toy example, but you can probably imagine how this can kind of compound and grow, especially when you get more complicated formulas. Um, One of these formulas that support dynamic array calculations is unique. So for example, suppose you have a, vector of class values and you want to figure out, okay, what are the unique records? So I can kind of, you know, maybe create a summary, kind of understand what's out there in my data set. Well, I can just type in unique and reference that vector, and it will automatically, um, pop out a reference or an array with all the unique references. And we can see that this behaves dynamically because if I, add in an E, it will recognize that and the output extends as such. Now, if I change that back to a D, um, it'll just drop back out. So that just kind of exhibits the dynamic behavior. So that's just a taste of dynamic arrays. I found them to be very useful exploratory data analysis and setting up dynamic exhibits and calculations that require pretty minimal updating valuation to valuation. Next off is Lambda functionality, and I would really encourage anyone, if you might have missed the talk earlier today, to go back to the speaker, I think Brian Rubidoux, who's going over some really advanced Lambda functionality. But essentially what Lambda is all about is defining your own function in a really simple and portable way within the workbook. If you've used VBA in the past, maybe you've defined function there. This way you can actually define a function within the named range editor. Um, and actually you can introduce a little bit of recursion if you want to really get fancy. And there are a growing suite of functions that allow you to create lambda statements and pass them forward, like to apply each row on an array, for instance, kind of in a dynamic functional programming kind of way. So just a couple examples here. We can see I've created a very simple Lambda function called myAdder, and I can see that it's taking an argument of 1 and a 2, and it's returning a 3. So I can probably figure out what this is doing. But if I really want to see how this is assembled, I'll go to the named range editor. Here we go to the name manager. And you can see that here, myAdder is defined with this Lambda statement. It has a little bit of documentation that I'm adding 2 numbers, and you can kind of figure out how this works. Lambda is kind of setting up Excel to know that I'm building out a function. Um, it can take an arbitrary number of variables or arguments. I think that stops out at about 200. And then the last argument would just be those variables combined in your function that gets returned. So in this case, I give it an x, I give it a y, and my function, myAdder, will return x plus y. And now once I have defined it, I can port it all around the spreadsheet. So that's how you would define a function yourself. Um, One thing you can also do is with certain functions like by row and by call, you can, within that function itself, you can define a Lambda function. And by row, for instance, we'll take that function and apply it to each row of an array. Now, here's an example here that I have on some claim data. What this does is starts with gross ground up claim data, calculates losses in a per occurrence excess of loss layer, and then calculates an annual corridor deductible. The losses, you know, from all, in this case, all claims in the 5x10 layer for a particular year, and it caps it at 7.5 million. And the way that this is accomplished is first starting with the let function, but within it, it first defines the gross layer by totaling the gross amounts indexed over the accident year using this lambda function. It divvies up the share by claim, then finally calculates the overall annual corridor amount and allocates it to individual claims. And really the key here that uses lambda is this by row. What this does is we'll take this function and just apply it by row to this one array. And you can kind of check the math here. Here's the gross amounts, here's the 5x10 layer, and you can see that on those years where it's, above 7.5 million, you can see it's doing its job and capping at that accident year. So we're all good. And that's just a brief taste of lambda functions. And again, I really encourage folks to check out the other, I think it's Brian Rubidoux, and check out his presentation today, because I think he's going to go really in depth to those. So getting back to our presentation, Excel Labs, this is I'm calling it an ad hoc add-in. You can, add it in just like you might do Solver or any other add-ins from the Microsoft Store. This comes with two features. It comes with an advanced formula environment. If you'll remember when I defined that adder function, I had to kind of type in the formula in a tiny little box. Well, that's not a great environment to write code in, especially if you write a really complicated Lambda statement. And the advanced formula environment is essentially a beefed up code editor to be able to write Lambda functions in a more proper manner. And then also there with Excel Labs, you get the option to use a generative AI prompt. But this actually does require an OpenAI account to be able to run those prompts. But you can call it in spreadsheet. Um, going for these last few ones a bit quickly. Power Pivot, this is a data modeling engine. This basically allows you to house multiple tables and define relationship structure between them, what's called the data model in Excel. If you've used Power BI, the way Power BI structures its tables, and you can create measures to calculate different quantities, summarize them, index them, sort them, filter them. It's exactly the same engine, and it uses the exact same language called DAX. This is really useful if you want to, create pivot tables, pivot reports that reference multiple tables all at once that have certain relationships. Really good for really good for dashboarding. And if you've used Power BI, if you're familiar with that, then you know about Power Pivot. This is just extending that functionality to Excel. And then finally, Potpourri. This is just a bunch of odds and ends. Microsoft Copilot, a lot of your organizations might have started pushing that out. This is really just, think Clippy, but with artificial intelligence, and it's available on several applications, including Excel. It can help you, draft code, draft formulas, maybe format things, do some exploratory data analysis for you. Office scripts, I would think about this as a more modern version of a record macro. This allows you to automatically record and share scripts. It uses a kind of a variation of JavaScript to do that if you want to go in and edit or build it from ground up yourself. But this is just another way to kind of, record and automate your actions. Again, Power Automate, kind of like Copilot, it extends to a lot of Microsoft products. It's a robotic process automation feature that allows you to, automate your processes. So you can spend your time doing other more exciting things. And then finally, for people who are, using OneDrive, you'll notice that there's lots of really helpful collaboration options with Excel, such as, users are using the same spreadsheet. And again, that's the end of this section. I do have a few resources if this is of interest to anyone. I did author a paper earlier this year with the CASU forum, and it went in great depth for those features that we talked about that are available locally. a lot of workbooks that I made that are attached as a zip file to that paper. Feel free to reach out to me if you're having trouble finding it. But I also had a lot of discussion of spreadsheet risk and project management considerations, along with just kind of that goes through a lot of these features, including a couple more I didn't talk about here. And then last but not least, I recommend, if you still use our blog, they'll have a few updates each month. You can catch any changes that might be that. A full stack platform. What do we mean? I keep using that word full stack. And if you're a software engineer, you might wonder if I understand what it means. And I can say that I am using it in a pretty loose term. Full stack just refers to, a software engineering process that builds out both the front end and the back end of an application. Um, and what I'm using it for here loosely is a full stack data science platform. What I have in mind here is a single application that can meet all your needs for, connecting to data, transforming it, exploring it, modeling it, and reporting on it. And typically, I think we all can imagine many ways that Excel might fall short of being a full stack data science platform. One of the big ones is that historically it's been difficult to keep data unmixed from business logic. You'll have people manually processing raw data, pasting it into Excel to use for your actuarial models. And that is really not ideal for a lot of reasons. It's expensive to update just in terms of time and resources. It's risky to update and maintain. It reduces auditability, and it's really difficult to scale. Um, and also, for people who enjoy, executing advanced modeling techniques, there's a lot of that has been out of reach. There's limited space in your workbook, even though we have, over a million rows. That's still probably not enough. You probably don't want to have a million rows of be working with a million live rows of data in Excel. There's a lot of performance issues there. Um, there's only a few elementary statistical functions that are built in, like, your linest, maybe a few other things. Um, there have been packages that have been built up, marketed, and a lot of organizations have them over time. In my experience, there's some really good ones for risk modeling out there. But for a lot of actuarial problems, those kind of solutions are kind of few and far between. Um, Many companies might develop their own approaches within VBA, but that comes with its own risks, just like maintaining spreadsheet environment in general, and it comes with a little bit of technical debt. Now, what I'm going to want to do is to propose a paradigm where we can think of Excel with all of these new features that have come out the past 10 or so years. Think of Excel as a possibility, as a possible full stack platform. And the way I conceive of this is that one, external data is kept sealed from the spreadsheet environment. There's no copying and pasting. There's no really human involvement outside of the spreadsheet to get the data in a manual fashion. Instead, what we'll do is use Power Query to connect to those data sources and prepare it for actuarial analysis. Once the data is in the spreadsheet, if it's in the table, the data model, a pivot table even, you can proceed forward with your actuarial models. Maybe you can even feed parameters into Power Query by a control panel within the workbook um, to kind of direct it to the proper data files to input. Um, if you have a need for advanced analytics, you can access Python and Excel. There's a lot of standard libraries that you can use now that Python is in Excel um, to get a lot of you know machine learning um, advanced models, kind of using them off the shelf rather than having to develop them in-house. And once those kind of exploratory and analytic exercises are complete, you can supplement it with Excel's own visual and summary exhibits. There's lots of review and documentation features available in Excel, and that can just be, you know, continued on as normal once your analysis is complete. Now, with the first of these two, kind of these two blue features here, I wanted to talk about is Power Query. Um, and again, there is I think Andrew Chan, he has an excellent deep dive today. Would really recommend anyone interested in this to check out his talk. I won't go in too deep, So Power Query, it's what's called an ETL protocol. That's extract, transform, load. It's low code, no code. I don't need to have to learn the base language, which is called M. I don't have to learn that to create effective queries that are really impactful. It's helpful, especially when you're wanting to do more advanced transformations, maybe link up several different queries that you've authored through Excel's prompts. You want to combine them in a more effective fashion. But in general, you can get a lot of bang for your buck without learning M. Um, what Power Query uses is a software technique called query folding that will take the query statements that you've authored in Power Query within Excel, and it will work to try and push some of that evaluation to external sources if those sources are databases like a SQL server to kind of improve runtime, not sap up resources on your own machine. And again, just like Power Pivot, Power Query is also embedded in Power BI. So if you've used Power BI, you've used Power Query. It's going to use M. It's going to have a lot of the same look and feel. There are, I think, a few differences here and there, but on the whole, it's a pretty similar experience. So what do I mean when I say extract? All I mean here is connecting to external data sources, and Power Query has a ton of sources they can connect to. They can connect to text files, folders of files, other Excel workbooks, um, access files, PDFs, web sources of data, and what's been particularly helpful in my experience is the ability to connect to a company data warehouse. For example, SQL Server. What you can do is embed code SQL statements within the code itself, and that gets pushed to the SQL Server and brought and the results of that SQL query are brought back into Power Query within Excel. A word of warning here, though, is that not all databases, particularly ones, not owned by Microsoft, have built-in connection support. So, for example, at my last job, we had a lot of our policy data stored in our EDW, which was a Cognos implementation, and I don't, and there's certainly at this time no kind of standard out of the box connector to Cognos via Power Query. You would have to buy a third party software to do that. And so that is a real limitation. In our case, what we did is we kind of worked with the BI team to set up kind of a monthly delivery of flat files with what we need. We put it on a share site. And so instead of having Power Query connect to Cognos, we would have it connect to that monthly flat file for all of our policy data needs. And our claim data would still come from the SQL server that was attached to our Guidewire claim system. And one really important thing to mention is that in addition to those external data sources, you can also connect to named ranges and tables within the own Excel operating environment. And the upshot of that is that you can essentially build a control panel within Excel with parameters like perhaps dates, valuation dates, um, names of files and directories, and pass that into your Power Query statements. And they'll recognize that and update dynamically to pull out, claim data valued as of, the new valuation date. I don't have to go into the code and change the date myself. I can just change it in Excel and hit refresh. Transform, this is what it sounds like. Once you get the data, you can apply all sorts of transformation, including, cleaning up messy fields and doing text analytics. One big advantage here, especially, as someone who manages people and reviews their work and is also very concerned with auditability, there is an audit trail that with each transformation that's introduced into the query, you can see each step and kind of go backwards and forwards if you need to, check or validate the work. And there is some AI assistance that's provided. If you aren't quite sure how to best transform or combine a few fields, there's a column from example that will use a little bit of ML to kind of build out the transformation that you're trying to articulate, but can't quite, stick the landing. And finally, load. Power Query will load data into the workbook environment in a few ways. By default, it goes into a table, but you can also put it into the data model or a pivot table, or just keep it as a connection only. Um, and this last point is something we're going to touch on when we get to Python and Excel, and kind of is the preferred way of getting data into Python and Excel is using that connection only query feature with Power Query. So again, kind of getting back to um, high level here about Power Query. So the queries are written in M, and the M script is automatically generated as the user selects the different steps for the transformation along the way. Um, if you are ambitious and you learn M yourself, you can open up a text editor within Power Query, edit the code, leave comments, things like it'll have a little bit of IntelliSense that helps you author queries and prevent errors, but it isn't a full-fledged IDE. So it's it kind of falls short of being a proper, software development environment. Um, I did want to, and this credit goes to Gil Raviv. He wrote a really great book on a lot of Power Query topics, but this was kind of his impressionistic way of showing in his experience um, how a knowledge of M can help with different problems. If only you're doing, the user interface, so like pointing and clicking and running through the automated prompts, that'll get you like 40% of the way there. Um, Even with just a little bit of editing M, you can increase that to 60%. And then you can kind of see it levels off here. But all of this is just to illustrate that you can do quite a bit without having to, burn the midnight oil and learn yet another language to get the job done when it comes to, extracting, transforming, and loading data into your workbook. A couple of actuarial use cases. And again, this would be for my last job when I worked at a carrier. So I led the reserving team. We also had some reinsurance duties as well. Um, it was a 2 billion annual DWP personal small commercial rider. Um, Most of our claim data for our captive agent books that was housed in a SQL server that was attached to a Guidewire claim system, reconciled to financials was great. We had some legacy claims stored in an actuarial EDW, and we also had baseline SSRS reports that we could use to tie our queries back. And these reports were baseline, so it made the auditors happy whenever we reconciled to those. So using Power Query, we could, embed SQL code into the Power Query statements to access the live claim transactions. We could write other queries to access that legacy data to build out our full triangle sets. And then we could also generate the SSRS reports um, as a third kind of family of data sources and pull all those things in together to build out our triangles, build out our dashboards and analytics, and then reconcile automatically. And the only thing we really had to change was things like valuation dates, the location of files on the servers for the SSRS reports, and maybe any additional data fields we might need to bring in. And so at the end of the day, this cut down on time in a really significant way um, with our monthly processes. We were actually able to get to daily reserve indications really really important for management when looking at actual versus plan, understanding the reserve movement month to month, especially if we get hit by a cat. What does that do for the results? Are any areas heating up and we need to get claims ahead of it before the quarter end? Things like that. And at the end of the day, when our big monthly IBNR exercises rolled around, we had a really good solid process, very auditable. Really didn't take much time to update each month or reconcile and generate, all of our reports. On the other end of the spectrum, we also had some reinsurance administration duties, and historically that involved lots of manual preparation of data, taking it off the claim server, maybe running it through a couple of spreadsheets, a lot of manual intervention, copying and pasting that data for different administrative like billing and then accounting exercises. So, at the end of the day, all of that data had started with that SQL database. So what we did, we just modified all of the data collection processes just to query the claims database directly. And we did have to supplement with bordereaux from our MGU business. Um, but at the end of the day, we were able to consolidate a lot of the separate processes, shave a couple of days off of our tasks for the reinsurance admin close, and we usually had a 4-day window to close. We went from something like 15 SOX processes on the reinsurance admin down to like 9 or 10. A lot of that was just simplifying our CAT procedures. Those were pretty complicated. A lot of contracts there, a lot of lines of business impacted, a lot of changes over time that we had to have a lot of different processes built out for. And at the end of the day, we were able to reassign one FTE within the actuarial department just because we had so many efficiency gains. We were able to, you know, move that individual over to doing some risk work. A really good outcome for the whole team. So that's Power Query. And again, Power Query's been around for a while. I think probably maybe 15 or 16, that's when it's entered Excel. So it's been floating around, percolating. A lot of people have used it. That is not the case with Python and Excel. Um, it has been in beta for a couple of years. And when I say Python and Excel, what I mean is Python scripting available within the Excel spreadsheet environment. This isn't like using Python external to Excel, which is a paradigm that some folks work with. This is kind of different. It's an actual PY function that you can do within the spreadsheet to engage in cell scripting. Um, but this has been, like I said, it's been in beta for a couple of years. The rollout accelerated this summer. If you have Microsoft 360, if your organization has Microsoft 365, you might have it at this point. Should try it out. Let me know how it goes. But you're able to, reference objects within the spreadsheet itself. So ranges, named ranges, tables, and queries to pull it into the Python script. And in addition to just kind of the base Python functionality, there are some well-known libraries that you can import. Names that a lot of anyone in the Python world would be pretty familiar with. Pandas, scikit-learn. Um, Now, that family of options is limited. So if you have, your favorite objects that you work with or your favorite packages that aren't in that list, and the list is on Excel's website, I'm not going to publish it here, but it's about 20 different packages. So if your package isn't there, you might experience a little bit of frustration. So that is a limitation to Python and Excel. That being said, these are pretty expansive. You can do quite a lot with it. Um, and then once that Python script runs, you can output the results into Excel, whether it be an array, a number, or like a Python chart. Let's see. And so with that, I'm actually going to open up a little toy example that I built, and this is and I can't take credit for this. A few of the ideas come from one Excel MVP, George Langer, that I've kind of reappropriated to an actuarial context and then added on some of my own. But let's go ahead and open it up. All right. All right. Apologize for that little hiccup. I think with the Zoom recording, things have slowed down for me a little bit. So what I have here is a pretty contrived example. What I've done here is bring in a pretty large vector of claims with their associated severity. Um, and this is artificial data, so there's about 100,000 rows here. I uh, I mixed a distribution of about 16 different or I mixed about 16 different loss severity distributions here, and I'm just kind of curious to see um, how material they are. Perhaps I want to do, some severity forecasting. Maybe I don't want to run through 16 models and make 16 different picks. Maybe I can, cluster them somehow. So what I'm going to do is import these data, do some k-means on it, and kind of see, one, am I actually picking up those 16 nodes, and maybe 16 is too much. Maybe I can do less. So what I've done here, kind of step by step, in each of these cells here, I have a different instance of Python. And the way to initiate this is simply to go equals py, and I can go ahead and type in Python code. I can add comments. It'll it'll potentially yell at me if I do something wrong. There's a diagnostics bar that'll pop open here once I commit the code if there's an error. And then once I have entered the code here, I can hit Control Enter to commit it. And just for the sake of kind of the sake of exposition, I've actually have 5 little snippets here. I could have combined them all. Um, one nice thing about Python and Excel is that there's an evaluation kind of row by row, then down the column. If I have separate Python statements, it'll kind of run it in order. Also, one important thing to engage is your calculation options. Um, I should set this to partial, and that way I have to manually refresh this. So hit F9 or Control F9. That'll save me on performance. So this first um, this first code, what this does is really just it reads in that last vector of the table on the other tab, and then it converts it to a data frame. And you can see that the output here, py, that tells me that the Python is executed and it's returning a data frame object. If I want to kind of unpack what it is, I would click on the py, and it will give me a preview. So yeah, there's my data frame. Thanks, Anaconda. Um, if I wanted to, I could change this to an Excel value. Because it's outputting the data frame, what it would do is just spit out the entire vector. It would, in this case, it would clutter up um, clutter up my workbook, so I don't want to do that. But we will make that switch down when we get to the images. What I've done next is run a very simple k-means classification with 16 clusters, because I know I put in 16 gamma distributions. Um, and this ended up with a k-means fit. Then what I wanted to do is you know, um, take those clusters, put them back on, run them back through a tree, and then create a confusion matrix just to see, how well it's fitting. And that's what's happened in this fourth step. And we can see that there's an image here. And say I want to just, maybe this is the notebook that I'm doing my work in, and I want to be able to kind of exhibit it. What I can do is return that image as an Excel value. And you can see it's working, #busy. I see a teeny tiny graph there, and so what I'll have to do is blow it up a bit to be able to see it. But yeah, pretty good fit. I can see that a lot of my values are falling on the diagonal, which I kind of expect. This is a contrived example. Um, but now maybe I want to ask myself, do I really need 16? And one kind of quick and dirty way to um, look at how well, relatively speaking, different numbers of clusters perform is what's called like an inertia graph or an elbow graph. And so that's what's happening down here. Um, this also returns an image, and I will also return that as an Excel object. And what this is going to do is calculate a statistic called inertia for different values of k ranging from 1 to 16. And the rule of thumb or the rule of elbow, if you will, is when you have this kind of quick turn, in this case it's maybe around 3 or 4, that's probably a good balance between complexity and performance here. So this is, there are better diagnostics you can do, but this is kind of telling me maybe, if I'm wanting to, at least according to the k-means paradigm, if I want to group my claims into different clusters for severity modeling, maybe I don't need all 16. Maybe there's enough similarity between some that it's sufficient to use a smaller population of clusters. So that's just a really quick and dirty Python and Excel example. I do have, I did have one other example I wanted to show, but for the sake of time, I'm not going to do that. Instead, I'm just going to point out back here when you're referencing Excel objects, say that you don't want to import a huge table into your spreadsheet, but you want to be able to put that data into your Python script. What you can do instead of referencing the data that's floating around somewhere in your spreadsheet, you can actually just reference a query that you authored from Power Query, and that will automatically run as well. So you're basically saving a bit of space. And say your Power Query outputs more than 1 million rows, Excel stops at about 1 million, then you'll be able to run it that way. So just wanted to point that out as so that's not something we're going to get into, but it's I think it's using Power Query to feed in to the Python statements is I think kind of the preferred way to go. Um, just kind of some concluding thoughts on this. This only came out to the summer. I think this is a right topic to explore. It's not something I've seen built out very much. For myself, I am trying to move a lot of the risk modeling I do away from like VBA and add-ins just to do Python and Excel. I like personally like having everything in, one notebook. Um, and again, because I'm on the reserving side, I'm kind of looking forward to trying my hand with some lasso and bootstrapping options, just kind of in the spreadsheet. One thing, and I think this might really make Python and Excel infeasible for a lot of people, is that there's a restriction to a fixed set of libraries. A few that I'm missing are Stephen Mildenhall's Aggregate, as a really good risk modeling library. The chain ladder Python. I know that's being presented on at this conference. Unfortunately, we wouldn't be able to deploy it in Python and Excel, which is unfortunate. It's a really good reserving package. And also PyMC, there's no, at least not that I'm aware of, kind of an easy Bayesian calculator or calculation engine within the standard suite of packages in Python and Excel. So if that's something that you're into, that you need to use, I think you're going to have to just kind of stay in Python or stay in other languages external to Excel. So with that, just some concluding thoughts. Just on the actuary in Excel, there's a CAS technology survey a couple of years back. They noted that Excel is ubiquitous. Um, Many users noted that Excel was highly relevant, and yet at the same time, they also wanted to upskill. There was a big desire to do that. And also, there was a desire to increase proficiency in Python, as well as R. But in general, there's a big disconnect between the amount of people who wanted to upskill in Python and the amount of people who are actually using it in practice. And I think the reason I feel like this is relevant is I think it speaks to a lot of the pros of relying strongly on Power Query and then Python and Excel. It's just a familiar environment. I think one of the slides earlier says it, Python and Excel puts the machine learning cookies on the bottom shelf. That's definitely true for myself. Um, Power Query is extremely easy to use. It's kind of fun to use. It's very, limited point and clicks, and you're able to bring in a lot of data and transform it in a really natural way. And just the kind of open-ended a kind of sandbox of the spreadsheet environment means it's easy to build a notebook that fits your needs, kind of your thought processes, how you want to walk through your analysis and document it. It's similar to the Jupyter notebook approaches in that regard. But with the pros, I also want to mention the cons. This is not a software engineering platform. There's a lot of features from an IDE that um, are not here. There's no Git depository that you can make for your Python and Excel workbook, at least that I'm aware of. And that kind of could hamper quality and collaboration features. This is really going to be infeasible for true big data. I think that there's a limit of something like 100 megabytes upload when you're running Python in the cloud. Um, Power Query lacks compatibility with some common data sources. I think in general that can be overcome, but it's something to be aware of if you're trying to connect to your company's EDWs, on whatever platform those are. And then discuss this a couple of times, but the Python and Excel is limited to certain well-known libraries, so that might really make it an unattractive feature for a lot of users. But with that, a big thanks, and please feel free to reach out to me on LinkedIn after this. Also, my email is there, and I'm going to go ahead and stop the recording and open it up to Q&A. So, thank you all very much.